Let's begin with our first problem. So the question says over here, if the magnitude of sum of two vectors is equal to the magnitude of difference of two vectors, right? The angle between the vectors we have to find, right? So first of all, let's figure out what is our magnitude of sum of two vectors. We know that sum of two vectors, let's call it as A and B. So magnitude of A plus B, that is equals to the magnitude of A minus B, right? Correct? Now here magnitude of A plus B, how much it is? We know it is nothing but root under A square plus B square plus 2AB cos theta, correct? Where theta is the angle between the two vectors, and A minus B, that will be how much? It will be root under A square plus B square minus 2AB cos theta. I hope you people are familiar with this particular relation, right? Here A and B are two vectors and the theta is the angle between the two vectors, okay? If they are inclined in such a way, like if here it is, this is a vector over here and this is another vector B and the angle between them is theta, then we find the resultant of these two, provided here be very careful, here the magnitudes of A and B which should be given, right? So squaring both the sides, it will give us A square plus B square plus 2AB cos theta, and that would be equals to A square minus, sorry, B square minus 2AB cos theta, right? Now we can cancel out A square and B square both the sides, right? When you cancel out A square with A square and when you cancel out B square with B square, what you left with is, let's take this 2AB cos theta on the other side, it will become 4AB cos of angle theta, right? And what you left with on the right hand side? You left with 0, correct? Now if I take this 4AB also on the right hand side, what I left with? I left with cos theta, that must be equal to 0. At what angle theta is 0 degree? For cos, the angle theta must be how much? It must be pi by 2, or you can say 90 degree, right? So here, as they have not given in radians, they have given in degrees, so correct answer for the first one must be option A. I hope this is clear. Now let's move to our next problem. Our next problem says 6 vectors A to F have the magnitude and the direction indicated in the figure. Which of the following statement is true, right? So as you can see, all of them are oriented in different directions, right? A is pointing in this direction over here, B is pointing downward, C is on the right hand side. So all of them are given with different directions. Now here we have to just recall our basics of triangular law of vector addition, which says if you have a vector over here, this is A, and if you have another vector here B, then the resultant of both the vectors will be R here, right? Now what is important to understand over here is the vector A, its head is this tip is head. So the head of vector A must be attached with the tail of vector B, such that the resultant will be starting from the tail of A and the head of B. Let me repeat again here, the tail of first vector is over here, the head of first vector is over here, and the head of the first vector is connected with the tail of the second vector, right? So let's see which pair is satisfying that. So let me just draw here first one. Let's see if the first one is correct or not. So B plus C, where is B? Sir, B is downward as per the diagram. You can see over here, B is downward and C is on the right hand side. So let me just draw here C like this. So the resultant of B and C must be in this direction, right? This must be the R. Yeah, parallelogram law of vector addition, right? So in parallelogram law of vector addition, if you are connecting both the vectors tail with tail, the resultant will be in this direction. Is there any vector which is pointing similar to this R? No. F is there, but it is pointing in the opposite direction, and if it is pointing in the opposite direction, we can't get our correct answer, right? So let's see our option B. Option B says D plus C is F. So let me just draw D here. D is pointing in this direction. C is pointing in this direction. Again, tail is connected with the tail. If the tail is connected with the tail, the resultant will be from the diagonal along this. So D is C, and is it F? Is F pointing in this direction as per the diagram? No. F is not pointing in that direction. So our correct answer is not B also. So B is also not matching here. Let's see the third one, D plus E. So D is pointing in the upward direction as per the diagram. E is pointing in this direction as per the diagram, and F is pointing in this direction. Now this is matching our parallelogram law of vector addition, right? So if two vectors are connected tail to tail, the diagonal of the parallelogram so formed, it will be our what? Resultant, right? So the option C must be the correct answer for this one. Let's move ahead and see our next question. Great. So our next question is A and B are two vectors and theta is the angle between them, right? Great. And magnitude of, let me write here the condition given here, magnitude of A cross B is equals to root 3 times A dot B, right? So magnitude of A cross B is nothing but AB sin theta. I hope this is clear. AB sin theta is the our result, right? Which result? Cross product. If you are not familiar with this, cross product says A cross B whole magnitude will be equals to magnitude of A, magnitude of B, sine of angle theta. Great. And what about dot product, sir? Dot product is A dot B, that is nothing but magnitude of A, magnitude of B, cos of angle theta. Correct? Okay, you can place magnitude here. Okay, so we can just rewrite this if you want to make it proper. Magnitude of A, magnitude of B, sine of angle theta. On the right hand side, it will be root 3 times A dot B. A dot B is magnitude of A, magnitude of B, cos of angle theta. Let's cancel out both the magnitudes. So magnitude of A will cancel out with magnitude of A, magnitude of B will cancel out with magnitude of B. Let's take the cos theta on the left hand side below sin theta. So it will look like sin theta over cos theta is equals to root 3, right? And sin theta upon cos theta is how much? It's a tan theta. So tan theta is root 3. For what angle tan theta is root 3? 60 degree, right? So theta must be 60 degree in case of, if it is given in degrees. In case of radians, it will be pi by 3. So let's see where our option says. Our option says it's in degrees. So option A is the correct answer, which is 60 degree. I hope this is clear to you. Let's see the next question. Okay, great. So our next question says vector A and B are such that magnitude of A plus B is equal to magnitude of A minus B. Though we have done this same problem in first one, okay, but they have repeated it, okay. They have just given an extra statement like this, okay. So same question, let's redo it, okay. In case if you have not understood in the first part, let's redo it. So magnitude of A plus B is equals to magnitude of A minus B. So magnitude of A plus B, that will be how much? So root under A square plus B square plus 2AB cos theta, right? And here it will be equals to root under A square plus B square minus 2AB cos theta. Now let's cancel out root on the both the sides. So when you cancel out root on both the sides, what you left with here is A square plus B square plus 2AB cos of angle theta. I hope this is clear. Now when you write it here, it will be A square plus B square minus 2AB cos theta. I hope this is clear. Let's cancel out this A square with A square and B square with B square. We left with here 2AB cos theta plus 2AB cos theta, right? And that is equal to 0. And that is 4AB cos theta, that is equals to 0. I hope this is clear. Next, let's take this 4AB on the right hand side and make it 0. So cos theta will be equals to 0. For what angle it is 0? For angle equals to 90 degree, or in radians it is pi by 2. So correct answer here is given in degrees. So let's write here option B. Option B is the correct answer for question number 4. Let's move ahead and see our next question. So question number 5 says if a vector 2i plus 3j plus 8k is perpendicular to the vector this, then find the value of alpha. Quite easy question. Let me recall the concept of dot product. Dot product says A dot B, that will be equals to AB cos theta, right? And if theta becomes 90 degree, if theta is 90 degree over here, then A dot B cos 90 will become how much? So 0. So straight away the dot product must give us the result as 0. Sir, can we use cross product? Though it will be little complicated in that case, okay, because sin 90 will be 1 and then you have to simplify, that will take a lot of time. So better is you to use a dot product. So here let me write first vector A, that will be equals to 2i plus 3j plus 8k. I hope this is clear. And B vector over here is 4j. Now you have to be very careful here. They have written 4j. It's not I. So first write I vector, which is minus 4i. Very common mistake students do over here, plus alpha k, right? Now let's find the dot product. So dot product of A dot B, that will be equals to how much? Minus 8 I dot I is 1 in case if you don't know. 3 plus 4, 3 into 4, that's 12, and that will be our 8 alpha. and we know that it has to be 0. So, A dot B will be 0 and it will be minus 8 and plus 12. Let us make it as plus 4 plus 8 alpha, right. Taking 4 on the other side, minus 4 equals to 8 alpha, and alpha will be equals to minus 4 by 8, which is equals to minus half. Is there any option? Yes, option C is the correct answer for fifth question. Let us move to question number 6th. Great. Question number 6 says, if A cross B magnitude is equals to root 3 times A dot B, then the value of magnitude of A plus B. So, for that, first we have to understand and recall our basic concepts of cross product. A cross B is nothing but magnitude of A, magnitude of B, sine of angle theta. I hope this is clear. A dot B you should be clear with, that is magnitude of A, magnitude of B, cos of angle theta. I hope this is clear, right. And magnitude of A plus B, this relation also you should be familiar, root under A square plus B square plus 2AB cos theta. I hope this is clear. Let us move ahead and see the other part. So, first of all, it is given that magnitude of A cross B is equals to root 3 times A dot B, right. And this will be nothing but AB sin theta, that must be equals to root 3 times AB cos theta. I hope this is clear. Now, let us cancel out AB with AB. Now, you can write magnitudes, it does not make any difference in this particular problem. So, that is why I did not write down magnitudes, but you can remove A with A and B with B, and you are left with sin theta whole divided by cos theta, that must be equal to root 3, and that gives us tan theta, that is equals to root 3, or theta must be 60 degree, right. Now, if theta is 60 degree, let us substitute this value in our A dot B. So, magnitude of A plus B, that will be equals to root under A square plus B square plus 2AB cos 60 degree. Cos 60 is half, if in case if you do not know, cos 60 is half, right. So, we can cancel out this 2 with 2 and we left with root under A square plus B square plus AB, right. This is our answer. Now, if you look carefully, they have not given in terms of roots, they have given it in terms of powers. So, in case if you are not familiar, the root is power half. So, here it will be power half, right. So, let us see now, is there any such option? Yes, option A is the correct answer for 6th one, right. Let us see the 7th one. So, what we will do here in this case is, we will take it as F1 plus F2, let us multiply dot product it with F1 minus F2, and this has to be 0 because they are perpendicular to each other, right. So, this will be F1 square minus F2 square, that will be equal to 0, or F1 will be equals to F2 magnitude wise, right. So, the correct answer is they are equal to each other in magnitude. So, option D is correct for the 7th one. Let us see the next part. Question number 8, it says if a unit vector is represented by this, then the value of C you have to find. Let me recall the concept of unit vector. Any vector is a unit vector if its magnitude is 1. So, if let us call it as any vector A, that is written as 0.5 I cap plus 0.8 j cap plus C k cap, let me just rewrite it as plus C k cap, then the magnitude of this must be 1. So, magnitude of A must be equals to root under how much? 0.5 whole square, 0.8 whole square, C square. In case if you are not familiar with the magnitude, let me just write it for you. If A is a vector AI plus Bj plus Ck, then the magnitude of this vector A must be equals to root under A square plus B square plus C square. And since it is a unit vector, its magnitude should be equal to 1. So, let me just write here 1 will be, and this will become 0.5 whole square plus 0.8 whole square and plus C square, right. Now, squaring both the sides, the root will go, it will become 0.25, this will become 0.64 plus C square, right, and that will become how much? 0.89 plus C square, right. Let us take it on the other side. So, it will become 1 minus 0.01, 0.01, that will become equal to C. So, that is our option C. I hope this is clear. Let us see 0.101 or 0.11. Be very careful here. 0.89, no, it should be 11. I have done a small mistake over here. It is 0.11, right. Let us see the next one. Question number 9. The angle between A and B is theta, the value of triple product. Now, this part you have to understand, this is a identity A dot B cross A, because if you interchange cross and dot you will get 0, right. So, correct answer for this one is straight away 0. This is our answer to 9th one. Let us see the 10th one. Which of the following is not a vector quantity? Speed, it is not a vector, it is a scalar quantity. Velocity, it is a vector quantity. Torque, vector quantity. Displacement. So, correct answer is option A. Speed is not a vector quantity, it is a scalar quantity. Let us see the last problem from today's lecture. The resultant of A cross 0 will be equal to, now be very careful, if A is a vector, okay, if you multiply a vector with a 0, it will produce a null vector, which is 0 vector. Be very careful. A scalar multiplied with 0 will give you 0. So, here A is a vector, vector multiplied with a 0 will produce a null vector. Clear?